Look at hypothesis testing with normal distribution. So let's first start with what we know. We know that a normal distribution can be represented as this. So we've got our mean and we've got our sigma squared, which is our variance, sigma being the standard deviation. Now, for hypothesis testing, we have to think about the sample mean normal distribution, and this is represented as this. You can see a couple of differences. Firstly, there's a bar here, and secondly, we're dividing by n now. So let's think about why this is the case. First of all, let's start with just a regular normal distribution. Here we've got x on our x-axis. Here's our normal distribution. What might we get a normal distribution? Well, let's consider screen use. Let's suppose you want to measure lots of students in a school and what their screen use is. So you go around asking all these students, what is your screen use? And they tell you lots of numbers, and you plot these. And you might find that you get an average of 4. Now, some students might not watch any, so they're getting down at 0. Whereas some might watch lots of TV, use their phones, iPads, etc. So they might be up at 8. But most are going to be at 4 and around. Okay, so how do we change this into a sample mean distribution? Well, you start off with your axes, but this time we've got a bar on our x. So this is now our sample mean. And what you do here is you might go into a classroom, ask all the students in a class if you decide that's going to be your sample. Your sample is a class of 30 students. So you go into one class, ask them all their number for their screen use. Sam might say 2.5, Jane might say 5.5, Freddie might say 4.5 hours. So you're going to add up all of these and divide by 30. That's going to give you a mean for that sample, that class. And you're going to plot that mean. And what you might find is that you first get an average of 4 for one class, and then you go into another class and you get an average of 4.2, and then you get an average of 3.8. And what you'll find is you get loads of numbers, but they all hover around 4. Occasionally, you might get a 5. And very occasionally, you might get a very low number, so maybe a 3. But what you're not going to find is a mean of 0, because in order for there to be a mean of 0, every single student in that class has to watch 0 hours of screen per day. And that's very unlikely. So you'll tend to get this distribution like this. And if you do this again and again with hundreds, even thousands of classes, you should find that you get a nice distribution like this. Let's compare our two distributions. We can see that one is much narrower than the other. They both have the same mean of 4, but our sample mean is narrower. So what represents how narrow or wide a distribution is? Well, it's the standard deviation. We know that a standard deviation above the mean to the standard deviation below the mean is going to be 68% of our area, or probability. So area is our probability in this case. What does that mean for our standard deviation of our sample mean? Well, we can see this also must represent 68% if we go above and below one standard deviation. But now our standard deviation is much smaller, and it must be smaller for the reasons we spoke about. We're no longer getting means of 0 or 8, but we're getting loads of means around 4. So all of this is to show that you must divide by n. It's a really big mistake to forget to divide your sample mean variance by n. So let's look at working out our standard deviation for x bar. For each of the following, write down the normal distribution for the sample mean, x bar, and also find the standard deviation. So we'll start with our formulae that we'll need. So we know that x bar is going to be the exact same mean, but the variance is divided by n, which in this case is 40. And the standard deviation of x bar, well, this is just going to be the square root of the variance. And if you put that into your calculator, you should find it's 0.648. And there are your two answers. It's worth noting that this is the exact value you should put into your calculator, not a rounded number. So that will stop your distribution giving you wrong answers if you can put an exact value for standard deviation instead of this rounded one here. So have a go with these three, A, B and C. Find the distribution of x bar and also its standard deviation. Pause the video. Right, here come the answers. Hopefully you got all of those right.